Hello, everybody, and welcome back. And now we start the discussion session for this morning. Let's maybe think about some topics that have been emerging during this workshop that we didn't discuss yesterday. So today there were lots of different talks and lots of different ideas. So I was just wondering how you felt this year. What are the emerging topics for you, and what do you think? Where do you think that the challenges are now lying, and what are we now solving? So we have a mic here that is on. So just everybody can comment a little bit.
I'm only here for 2 days, so I have to pass.
Goodness me, and I sat further away strategically, so I wouldn't have to answer first. So one thing that I'm very excited about that hasn't really actually been touched on in this conference, if I may, is the idea that lots of the organizations that we work with are, especially companies, are very private about their data. Company A has a data set, company B has a data set, company C has a data set, and they regard those as the crown jewels of the company, guard them jealously. But there's remarkable benefits to be had if we can somehow bring the information of those data sets together. And this is often in companies' best interest, that it might be a customer and their supplier that are working together, and they want to make the best materials so they can then go on and put that in an excellent product that would sell well. And so there's a field called federated learning that's exploring different ways of doing this, and there's advantages and disadvantages, the different approaches, but it's something that I'm very enthusiastic to drive forward.
Okay, then maybe I can connect to this data. I think this is the biggest problem, right? Self-driving cars have lots of data because every child can click cars on an images, but in material science, not even an expert can click molecules that have best, I don't know what property, right? So for that reason, I think data really is a huge challenge. And now we have this initiative to always also upload the data from, let's say, at least scientific community, which is a huge progress. But maybe something that I would add here is something, and something that we are facing with, a challenge, is that a lot of the times this data that is actually published is not exactly has some problems. Let's put it like this. Let's say we recently had some idea to do active learning on some database of metal organic frameworks, and we did it. Our method worked great. We were super happy, and then we later realized that there are like 10% of duplicates in the data set, which we didn't construct the data. I would never think of this, and it's only like randomly that we actually noticed this. So I would say we also have to implement some kind of measures how to get data sets that are really curated, as well as data sets that are easy to use, that I'm not spending a lot of time trying to figure out the data, but that they are more plug and play. And that, I think, would speed up our research in general.
This looks pre-made because it ties so well. And I will keep going on this train. And in particular, I will focus on benchmark data sets. So one of the reasons the machine learning community has had such a fast pace of progress is because there are very good benchmarks that people all over the world can compete and get better at and have a numerical feedback on how good their method is. This is somehow lacking in the realm of materials and, well, maybe a bit more on drug structures, but in particular in materials, we don't really have good computational benchmarks that we compare about. That some are popping up right now, but even there are some issues. For example, we have discovered that only predicting energies is a very minimal benchmark. We should have more complex tasks, more tasks that tie into simulation and to real property prediction, because at the end of the day, that's what we want. We don't want the energy of that thing there in void. That's quite useless. We need real property prediction. So yes, there has to be a strong push towards curated, publicly available, and well identified metrics in these databases that we can use as a benchmark to push forward and to really compare models and compare computational approaches, which we now kind of cannot. Basically, everybody that develops a method picks 3 or 4 data sets at random or with some reason behind between the 20, 50 that are available. So yeah, that's what I think.
All right, fully agree with the previous opinions. So I guess that, like, well, in this event we have seen that that the applications and uses of machine learning, they are more and more practical. So we are getting starting to get useful results. And I would kind of perhaps suggest that probably this is going to split into 2 main application areas in the coming years. So firstly, we have like the higher throughput, more automated application area. And in that area, lack of data and lack of machine learning compatible data is a big thing. So we need to start thinking about producing data for the machines instead of trying to use the data made for humans. So that like we just try to clean it up. We have to design the data generation so that it's compatible with machines. So this would be, at least in my view, one line, and the other line would be like actually the machine learning method assisting humans. And in that line, perhaps the data is still like human compatible data. But yeah, I don't know if you agree.
Yeah, I think now Sami is inspired.
Yeah, I didn't want to start because the question was that what has happened here during this week, and I wouldn't know. But now inspired by what you said, I would like to, if you are thinking of kind of what are
a bit closer to.
Okay, well, if you are thinking what are the main challenges, so I can tell 2, even though I'm not in the field. So inspired by the benchmarks, I think I'm actually very unhappy that machine learning has become a benchmark-driven science, because there are not enough benchmarks, and the whole field becomes overfitted to the small set of benchmarks, which is a really, really big risk, right? So in addition, people need to actually solve real problems and the real new problems. And this is what you guys could provide, right? So if you can set up a challenge that draws the machine learners to contribute, then you get for free a lot of people who are now looking for kind of more serious things to do than working on those toy benchmarks just to beat their fellow doctoral students, right? So, and I think this is a big opportunity, and this virtual laboratories movement is meant to make it easier. So if you can set up a virtual laboratory so that you can run benchmarks on simulations on a more important problem than the classical machine learning ones, you could get this up and running quickly. And I think that at least Patrick here is well within this, so he certainly is interested in talking about this, I think. Then the other thing is who builds the first foundation model for material science will be making big progress. So who wants to stand up for the challenge?
Yeah, something that Sami missed. I guess now, well, Armi gets the mic. Do you want to comment first?
Yeah. Just very quickly that we could, of course, organize a workshop to generate those benchmarking data sets, so both large and small. But
I was just going to say, because I think during this workshop, because there was so much talk about active learning, and all of those talks on active learning was generating the data on the fly for the problem that you need to solve. So these were quite unique data sets being generated. And yesterday in the discussion session, we were discussing, let's also publish these data sets. They can be a little bit unique. They can be a little bit specialized for the problem for which they were generated for. But nevertheless, they present new wealth of data in many ways. And they are not those kinds of generic benchmarks that people have been playing around before. So I think what we're going to see in the future is just more and more and more data sets coming out. Some that are very generalized and perhaps useful for comparison, but not necessarily transferable. And others that are very specialized. And if you train your machine learning model, you could have very, very accurate and transferable results, but maybe not to different kinds of problems. So I think in the future, people will definitely have much more of a choice. And we're already seeing this emerge quite fast. How we're going to store all of that data in 5 to 10 years time, I have no idea. But it's very positive. I mean, we've all been preaching to the converted that we should be publishing our own data sets. And I think now this is, the community is now adopting this. But I think we're going to see a much bigger diversity of data sets in the future. So it's very interesting what you've just mentioned, and also Julia, that there's not been much work on quality control of the data sets, quality metrics. We could actually design metrics that are somehow general enough to assign quality control to different data sets. So the same quality metrics for different data sets, so that there is a kind of universal standard. I don't know, Sami, you've been in the field working with very different domain applications. Have you seen this kind of generalized quality metrics for data sets? Has there been push from different areas to address this issue?
There certainly is. I mean, all fields want to standardize their data somehow. So as far as I've seen it happens field by field. And then there is, of course, some meta level on kind of databasing and so on, which would be computer science. So those things can be standardized, but what is important in each specific field is very different beyond that you have to somehow assess the level of noise and so on. So I think it has to be, some part of that needs to be field specific.
But it strikes me that there are a lot of generalized ways that we can approach it, like duplicates, noise, the level of diversity, the level of redundancy. There are some really generic measures that we could just attach to every data set. Yeah, outliers, yeah. Yeah?
Perhaps even before then, so there's other things we need to generalize about or agree on about our data sets. As we heard from Matthew Evans earlier this week about the Optimade effort, which is a much more basic problem. Can you just even access this data before agreeing about what to do on duplicates? And then there's the EMMC, the European Materials Modeling Council, that's put an enormous document about a generalized materials ontology to try to at least get us so we can even just talk to each other about these materials. And there's quite a few other efforts out there in the field. So I think that kind of thing, just so we can speak the same language is important.
Yeah, good point. I just want to mention that this is a joint discussion. So if you have any questions or want to make a comment, just raise your arm, and we have people with mics. And also for the Zoom participants, feel free to write in the chat and interrupt anytime.
One, two, okay. So just a thing about the data, the diversity of the data and the heterogeneity of the data is, I think, one of the problems if you want to aggregate all this in interoperability part. Okay. What are the thoughts about the diversity of the data coming from experiments which have different kind of outputs and also I would say the numerical part, which are essentially atomic at the atomistic scale. What do you think about that? Thank you.
Sorry, what was the question?
The question is, have you any thought about the heterogeneity of the data that could be aggregated?
So data coming from different sources.
Yeah.
Armi has an opinion.
Yeah, so I guess that firstly, to get more practical machine learning results, we need data from multiple sources. So it's good that we have different types of data, but we need larger data sets from one or for every single application. So from my viewpoint, for example, for experiment, we need more automated devices so that we can actually provide larger data sets for those, for example, for the benchmarks. And I had also another point, but I guess that I forgot it on the way.
We can come back to you. So if anybody else wants to comment on heterogeneous, Gareth?
Yeah, and we found that when you get data from different sources, each of those sources can have different levels of reliability and trustworthiness. So you mentioned outliers earlier. And so one little technique that we've been trying to develop and apply is to train on all the data, then go back and re-predict all the results. And then you can see some databases seem to have a few more outliers in than others, and you can associate a trustworthiness score, which allows you to re-weight those data sets and then maybe put less emphasis on the ones that appear to be less trustworthy when you train your final model.
And that could be another quality metrics, so trustworthiness of a data set and techniques to evaluate it. And I think also maybe in the coming years, we'll be seeing a lot more talks about data fusion approaches, where I think now we've kind of covered how to do machine learning on individual data types alone. But I think what's quite unique about material science is that you have this source of different channels of information about the same material or about the same problem or objective. And the question is, what are the frameworks and algorithms that will allow us to extract knowledge from these different channels of information? So I think maybe that's something that is in the development. But even then, I think all of the raised points about trustworthiness and data quality of the individual channels will also be an issue. Yeah, we have to be careful. Armi, did you want to comment more? Okay. I think we have a question from Patrick himself, so go ahead.
Yes, I have a question on human data. So tying into the talk that you gave, Sami, this morning. So one term that's come up in this conference has been crowdsourcing. So getting not just one expert, but a whole community of experts that can maybe not dedicate a lot of time to it, but each one a little bit, right? And this is a much more heterogeneous source of human information that could be or could not be useful. I was wondering, in this human in the loop concept or the AI assistant development concept, if there's a place for crowdsourcing and where it could be useful and where not.
Right, there certainly is a place, and there is several people working on what they call citizen science. So kind of crowdsourcing, for instance, in astronomy, they have operations that they are doing in this kind of. There's lots of people who want to contribute to astronomy and who may actually be really experts after reading about astronomy all their life. And they are interested in doing things like categorizing galaxies and so on. So if even going to laypersons in this sense is possible, then you need to formulate the problem of in what sense is the bunch of people a good instrument on gathering some data. But you can ask this question as a data analysis question or statistical question, that what is that bunch of people better for than doing alternative techniques. And that work is ongoing. So now crowdsourcing, then people who have expertise and where you would want to, I mean, in both cases, you would want to minimize their time and get maximal effort with the time, but especially as with yourselves, for instance, you wouldn't want to probably waste a lot of time in contributing to challenges unless it really helps. Then yeah, that is happening. So of course, kind of recommendation engines are a big kind of massively used toolbox where essentially, which are kind of solving the reverse question, but I mean, you can reverse engineer the solution. So many of these technologies exist. Whether there is already a mass movement on doing this really well, that I don't know.
Any more comments on the human in the loop solutions?
This is actually more like a question than a comment, but yeah, would those like machine learning assisting human solutions, would they be more designed for cases when you have a new application or a new problem and then human doesn't really know much about it, and you need to somehow collect the knowledge or acquire the knowledge quickly? Or is it more like you have this, you know, friend with you or colleague with you all the time for a long period of time in applications where you like you know that you are going to use it in a roughly same way for a different application for a long time. I hope that this question made sense. So,
would anybody like to comment?
Actually, I think maybe this crowdsourcing already in some way, maybe Claudio can comment actually, maybe already to some extent exists in these research companies, right? It's a huge environment. And for that reason, it's already a lot of people working together on the same problem, right? It's a lot bigger environment than, let's say, a single research group that has a lot less people.
Yes, so I think there's a distinction between human in the loop, let's say, approaches that use crowdsourcing and human in the loop approaches who use experts. In the former, you need a problem which is easy and fun to tackle, really. I don't think anybody in their spare time goes home and runs a DFT simulation because it's so much fun.
Well, speak for yourself.
Okay, maybe some of us do, but most of us don't. While many people actually look at the stars or like to take pictures of wild birds. That's where these crowdsourcing approaches work. In our case, I think it's hard to find tasks that suit this particular approach, while it's much easier to get a committee of experts. But unfortunately, experts also don't like to spend their time to freely give their time to rate this molecule from 1 to 10. And therefore you really need monetary compensation for that. Therefore, you're always limited in some capacity to how much you can have this human in the loop. As for the big projects, well, this is, let's say, a orthogonal approach in the sense that it just allows for pushing the boundaries of science in a more concentrated effort rather than disperse. But I don't think this solves, unfortunately, the problem of if we need human labeled data, we have to gather a lot of humans, which are very good, therefore cost a lot of money. So my question to you, let's rebound question because it's fun. Can you think, and this is for you too, like everybody should think about this question, is there a task in our fields of expertise that might be diverse that is well suited for crowdsourcing? Can you think of one? Because that would be amazing. If you could develop it as an app on the phone and have a nice interface and people actually being excited about gathering data for you, that is free data.
You mean swipe right on the molecule?
Yeah, exactly. Swipe right, swipe top for a very good molecule. So yeah, can you think of one of these examples? I can't.
Yeah, maybe Kim can later comment on this. And she was trying to introduce this very same opinion. Yeah.
And just a lot of pestering. That's
right. Pestering is the
for the case that I was talking about. It took like 2 years to gather those 10,000 data points or something from the experimental researchers, and loads of people went, oh, that's a really cool idea, I'll do it, and did about 100 data points and then stopped, and then that wasn't useful for us at all. So we only got to the sort of thousands that we needed from the people that I could just pester or had something else that I could hold over them, basically.
But that is a very good point, because there are also limits to what we can get from individuals, even if they're very, very motivated. So I guess the idea is then to gather very different kinds of opinions together from people who may be experts and people who may not be experts, and then somehow have a defect tolerant methodology to extract knowledge from all of this mass of opinions.
And perhaps another comment on this is to think about what would happen in industry. As I mentioned before, the companies are extremely private about their data and would never even let it sort of leave a room in their building, and only a couple of employees are ever allowed to see it. And so it just seems unlikely for that pile of use cases that we could ever envisage some form of crowdsourcing.
But do you think that they would be less private about their opinions? So if they were asked about data that is not theirs, do you think that they would be more willing to encode their expertise?
Well, yes and no, but they've got their jobs to do and will want to be paid.
Yeah.
And often we also, well, I see their data is so they've got such idiosyncrasies, like so which doors did they have open to get the right airflow through the building for heat treatment, that it just doesn't transfer very well between different companies.
True that. Yeah. Yes, Andre?
I will have one more question comment on it. Once more, bring me to the natural language processing thingy, because, for example, yesterday we heard about how concrete is good. I guess in industry there is lots of data, like one day the concrete is great, the second day the concrete is great, and there has to be some kind of like workbook when somebody write this. So this could be another source of information, maybe not the the swipe thingy, but another way in the same how to get the same data, and it's already there. It's just how we can access it. That's maybe the other question.
So that there is a lot of research now going on in this, and I think it's going to be, in a few years' time, it's going to become just another channel of information, heterogeneous information type that can be merged, and ultimately it can be used as a form of human opinion, or some kind of different latent model. I don't know if anybody wants to comment on this. Claudia?
I agree that there is a lot of data that is just there and nobody touches it. And I think the biggest example of this, as some of you are already working on this, is literature. How much data do we have in literature that only few people know about because they wrote the paper or they knew the person that wrote the paper? And I think that now that we are just at the time where large language models are able to process this data, we're just getting there. And I think in the next few years, and I'm talking 1 or 2 probably, we will be able to really scrape the data from the internet and now create a uniform, somehow uniform, maybe many people will do it, but at some point probably there will be a uniform database that scraped off the literature. And while it will not be perfect and we will have to deal with that, will be much better than remembering the name of the person you talked to a conference 5 years ago. So I think that's a direction where we will probably gather a sensible amount of data in the next few years. But of course, we have to work very hard and to tackle all the challenges that come with data scraped from a language model, which has its own flaws, of course. So I'm hopeful, but of course, it will not solve all problems.
I don't know if Matilda wants to comment on that, since she's actually doing the scraping.
Yeah, I kind of think that Claudia has a point here. So I think that these language models are already very capable of extracting a lot of data, or maybe just scrape data from internet, from all of the different literature materials, articles and theses and whatnot. But the thing is the accessing the materials and accessing the articles and how open access they are and how they can be the data then scraped, data obtained with these large language models, how that kind of data can be published, and what kind of databases it can be gathered and how kind of interpreted, so that we don't run into very big problems with all the publishers and stuff.
We've been experiencing a lot of difficulties with that. Just assembling good data sets is very difficult. Web scraping is not a good strategy. It's not very systematic, but many publishers do provide APIs, so backend APIs, but they're very, very specific about it and they're very unwilling to share the data ultimately. So it's quite a challenge to assemble any data set. And I wonder if the publishers in the next couple of years will change their strategies as well, because it's clear that this is coming more and more, and this information will be more and more in the public domain. And then even when we do assemble good quality data sets, it's very difficult to share them. Of course, we'd like to keep it open so that other people can also develop on top of them, but we're bound by copyright. So everything we assemble ourselves, we have to keep on the wraps. So, or privately share them or something. So it's been a bit of an ethical issue as well, how to get around the publisher's constraints. So I think that's something that's been slowing down a little bit the text work that that you've discussed, Claudio, and that Andre was raising.
Do you have a question on that? What about our archive? Can we just scrape off the LaTeX?
That is quite open, and that's quite easy.
So if you only restrain yourself to archive, which in the latest year, archive should basically one-to-one match publications, because almost everybody is pushed to have an archive
Unfortunately,
copy.
we're finding that archive is just a small fraction of the total data sets we can recover from Elsevier, Springer, Royal Society of Chemistry, and other big publishers. I mean, when we've covered from all of them, an archive is just a small fraction.
Yes, and the problem with the archive is actually that all of their documents can be obtained only in PDF format, which is very difficult to convert into plain text reliably, and so that all of the formatting is maintained.
Yes, so it's also very field dependent. So some fields have a lot of archive papers and some do not.
Exactly. I think that's something we didn't see coming when we started, but yeah.
But okay, it's not like you publish all the data in the paper, right? A lot of the data, main data, actually, you publish mainly in the results. Again, the specific to the specific discipline. But most of the data is somewhere else, right? So scrape GitHub.
Yeah. Well, and then as Maria Chan also mentioned, a lot of the data is in images and spectra and tables and things.
Yeah, and of course, in a lot more long term, we are hopefully going to have electronic lab notebooks, and then we have those like unpublished data sources, especially if you have a large unit, then you could, in principle, actually utilize those lab notebooks too.
Yep. So there were some questions here, but Hilda, if you want to go first. Yeah.
There was a comment
From
here.
Zoom.
In case of literature, copyright seems to be a big issue. It is rather expensive to obtain license for scraping text, even from non-commercial societies like ACS.
Yes, so something that, I don't know, Matilda, do you want to take that question?
Yeah, well, multiple of these publishers, I mean, usually universities have access to the articles and journals, so they kind of allow us then to do web scraping or scrape literature via APIs if we have the access to the articles. But yeah, then we can't publish those articles, like to give them to anyone else. So yeah, it's kind of an issue.
So yeah, so we don't have to pay a subscription fee to recover the data sets. We can recover them for free based on our university subscriptions, but then we keep them under wraps. Go ahead.
Okay, thank you. I also have a question that's very similar to the database problem. Is how can we best use a lot of models that has been already developed? For instance, it's also a very hot topic for computer scientists to develop some models for atomistic modeling. But from my experience, these models can be very nice. The accuracy and in terms of many properties is really good, but it's sometimes too difficult to use them because they are mainly use these models. They are mainly developing these models on based of some public dataset, and indeed they don't have very useful API or interface to the code or software we need to use, like MD or Monte Carlo, like these things. So how do you think we can make how can we make efforts to integrate these studies in computer science and in material science or chemistry together to make this field to be better?
So you're asking about the algorithms? How to use the algorithms better?
It's not the algorithm, it's the
Model,
interface.
the interface
Yeah,
to the algorithm.
Yeah, it's because there are already a lot of useful algorithms in machine learning models, like for machine learning potentials. But how to use them, and how can we how can they be integrated to some popular code for for people using these computational tools like LAMPS or like these things.
Okay.
Yeah.
I think that this is a problem, but I also think that it's going to solve itself, because everybody that publishes a model that is promising, but then does not provide any interface with LAMPS, let's say, well, that model would not be used. And there will be other models that will provide the interface with LAMPS, and people will use those. And actually, we already seen these. Like, I don't know how many potential models have been published. 20, 50, I don't know, something like that. And only those that took the time to provide a usable interface with the MD simulation tool of choice are actually being used by the community, and not only internally by those who developed it. So it is frustrating, but I think it's also a self-solving problem in this sense. Maybe others think that differently, but that's my opinion.
One second, we can't hear you, and the people on the internet need to hear as well, so yeah.
Yes, you're very right. But the problem is that, for the development of these models, they are quite fast for these people in computer science. And indeed, if we can provide some just interface, very easy to use interface to integrate all these models, then that will also be very fast for chemists to use this model. You use base of all these good models to use, and it will also accelerate our studies. I do think so.
But that's quite a lot of effort, and somebody is willing to do it. If the person who does it, or the group who does it, will definitely reap the benefits. So please, go ahead.
We have some comments here. Yeah.
I have two comments on the two previous discussion points. So first, for the earlier on the venues and publishers being too strict about the copyrights. So don't publish there. Establish an open access journal. That's what machine learning field did, and it's working really fine. So why are you guys paying the publishers about this? Do it yourself. The second is the solution to the previous question is virtual laboratories. You are welcome.
Maybe I can comment here in this last question. I think, like, I agree with Claudio, this will be solved. It's just there's a time lag. So I can maybe comment from the previous, so I previously worked on, or I still do, on multi-scale modeling, when we combine several different models into the same simulations, like concurrent multi-scale simulation. And when we were developing this, we basically had a code, and it was very like user specific. We hard coded a lot of the stuff, so it was not really from a computer scientist implemented, right? And so we developed a lot of new things, improved the method, and so on. And it's only now, so like 5 years later, that now we have this in, let's say, these methods in GROMACS. We have an initiative soon, it's going to be in LAMPS and so forth. So I see this as these machine learning potentials are now being developed. Like, we are still trying to figure out which is the best architecture, right? New architectures come in like in a year, you have 10 new architectures, right? And we're still looking for the one that is going to be actually cheap enough. So from that perspective, like the field is still evolving, right? But in 5 years, I'm sure this will be integrated now then in standard codes and usable to a general, biologist or chemist or whatever that just wants to, press a button and run.
Okay.
Hi,
question?
yeah, so I guess I've got one for Gareth and one for Claudia. So Gareth, I'm quite intrigued by the idea of federated learning. I wonder if you could comment a little bit more about how that's going to look like in its evolutionary pathway. And for Claudio, so there's this like idea that I'm sort of getting out of you from having these toy benchmarks and gamifying the entire process just to unleash some kind of inner fetish that all material scientists are born with to do DFT calculations on our own free time. I'm just wondering, like, what do you actually foresee how a benchmark like that is going to look like?
Thank you for asking about the federated learning. So maybe there's two different tracks that we're seeing emerging in the field. There's one where you would train maybe a neural network on data set A, and then that neural network is posted to the owners of data set B along with some other sort of weighting factors behind it. And then it is fine-tuned on the information of data set B, and the weights are changed slightly, and then it's posted onto data set C and it's retrained again. And that's great, and you can do so in a very secure way where you prove analytically that you can never reconstruct the data, but it's also got some practical disadvantages. That what happens if group A wants to withdraw from the consortium, then you can't just remove their contribution, you have to retrain the whole thing again. Or if you've got thousands of members of the consortium, then it's going to take a long time to daisy chain them together. Or if they want to each use different machine learning methods, then you can't put them together. But then there's a separate approach where indeed you would train separate models on each of those data sets. They might even be able to be different methods. And then you have an engine at the center that would bring those together where naively you could just average their results, or perhaps you could somehow weight them in a clever way, depending on the trustworthiness of the data sets, how much data they had in that region, etc. So I think they're the two directions you see it going, but it's a very sort of early days, but very exciting days in the field.
And thanks. And to comment on your other question, so I don't think toy benchmarks is the way. I think we need real benchmarks which are tough and produce properties that we're actually interested in. So I will speak for machine learning force field because that's my field of expertise. But something like property prediction, like complex properties that emerge from the dynamics of the system, for example, I don't know. Easiest. One of the simplest things that comes to mind is melting temperature. That's not trivial property to get for solids in molecular simulation, and it requires long simulations at high temperatures where your system has to be reliable and to have basically it checks many boxes that are actually then useful for molecular dynamics. So of course, this hinges on the previous comment that we kind of need something that ties the model to the prediction of the property through molecular dynamics. So that's required to get these properties, but that's also a good push for people to develop tie-ins to existing MD simulation tools. So just, for example, just a list of these properties on challenging systems. I don't know, silicon surface reconstruction, if you're doing silicon, or there are quite a lot of them that just come to mind, but just, yes, so going beyond single point evaluations of energy or force, but something that requires you to really simulate the system, to challenge yourself, to go in areas of the training set you never thought about. Sorry, areas of the phase space you never thought about. That's what we actually need to get usable models that are just beyond bold numbers in a table.
Any last comments?
Yeah, just a small comment that yes, we indeed need more modular approach, and we kind of, I guess that us scientists should do a bit more software engineering also and get used to that. Yeah.
So we're getting to the end of the discussion. I don't know if there's any last minute questions. Yeah, maybe there's one there. Yeah.
Hi. So speaking of crowdsourcing, so I'm a experimentalist most of the time. So I have some concerns. So like, because it's always very hard to like reproduce experimental result from others. That means that I think it's that there's a lot of hidden variables that people don't really know about, so that didn't report. Or maybe it's because like, if you ask someone who uses a furnace that when's the last time they like calibrate their temperature, it must be like a couple years or maybe 5 years ago, so that they have extremely large uncertainties on those data points, and it's inherently sparse. So I hope to hear some comments about like how to work with those kind of data.
Okay, so yeah, coming back to data quality and uncertainties.
And also like from model perspective, so that's an excellent example of like, well, when you're developing a machine learning model, quite often you just don't happen to like think about these like application difficulties. So I guess that we are going to see models that are better at handling different types of uncertainties, and also iterative approaches that are more reliable, so that they, well, at least I hope that at some point in future, the model may be able to let us know if it thinks that there's something weird, for example, in the distributions of the input variables.
I think this is a really good question about some real life practical issues. And we heard just in the last session, a talk about one way of handling missing information. And I presented a different sort of approach, and there were others also out there in the field. And in terms of uncertainties, I think they should almost be we should be very pleased that you're putting your uncertainties, and then find out ways to sort of exploit those by putting into different weighting factors on different pieces of data, perhaps. And then another approach is looking for outliers in the data, that we found it very useful to go through, train a model, do the retrospective, go and look for outliers, to highlight which are the entries most likely to be outliers, and then go back and look at them, and either they may well be outliers, need to be removed, it might just be a blunder that the decimal point was put in the wrong place, or sometimes there's new exciting hidden sort of chemistry hidden in those outliers, that in a kind of active learning sense, which will then motivate further investigation.
Yeah, and this is also related to the modular approach. So for many of these independent challenges, so we already have some kinds of methods out there for those, but it's quite time consuming to try and tie those together because we don't have existing systems. So yeah, hopefully in future we have better modules.
Right, and let's see where we are this time next year with this discussion. So thank you very much, and thanks again to all of our panelists. So I guess now we proceed with the part of the program. We have a few more talks. Are you able to start the, so you could try to put it without doing